So today we'll do notes 2.8 and the topic is inequalities. So first of all, if you think about polynomial inequalities, to solve f of x greater than 0 is to find the values of x that make f of x positive. To solve f of x less than 0 is to find the values of x that make f of x negative. So again, we're looking for x values that make y values positive or negative. If the expression f of x is a product, we can determine its sign by determining the sign of each of its factors. A sign chart, some people call it sign chart or sign patterns, shows the x-axis as a number line with real zeros displayed as locations of potential sign changes. So again, we're looking for potentially where the graph, for example, if our graph looks like this, what x values would correspond to positive or negative y values. So again, you need to know where are the places where potentially your y values could be above or below the x-axis. The first example shows that a polynomial function changes sign only at its real zeros of odd multiplicity. So let's go ahead and think about that example. So for number 1, go ahead and pause the video and again, go ahead and graph this. I know we've been getting really good at bounce pass graphing. So pause the video and sketch a graph without a calculator. Okay, so now I have some questions. I might want to know, where is f of x equal to 0? So again, I'm asking you, what x values give you y values that are equal to 0? So you would say x equals -2, x equals 1, and x equals 3. Okay, so now I want to know what x values, for part B, give you y values greater than 0. So go ahead and pause the video and do parts B and C. Write your answers in interval notation. Go ahead and do that now, please. If I want to know where the what x values have y values greater than 0, again, I would look from -infinity to -2 and 3 to infinity. I highlighted in the green the pieces of the graph that would have, again, y values greater than 0. If you want to think about y values less than 0, that would be from -2 to 1, and then again from 1 to 3. And again, I use the blue highlighter. Those are the pieces of the graph that, again, would have y values less than 0. Let's go ahead and take a look at another example. So we're going to solve for x. But again, before we do that, I wanted to show you a sign chart, actually. So let's think about, I solved this graphically, but how would I use a sign chart? Okay, so again, a sign chart, we're going to pick values of x where the y, or I should say the graph, could potentially go above and below the x-axis. The y's could potentially have a change of sign. So notice at -2, 1, and 3, we had zeros of the function. And now think of something that for x, and again, I'm looking right here, think of a value for x that would be larger than 3. So how about like 10 or something? So if I have 10 minus 1, that's a positive number squared. If I have 10 plus 2, that's a positive number cubed. If I have 10 minus 3, that's a positive number. So positive times positive times positive is positive. So we'll have positive y values again, which, take a look at the graph, that is correct. When x values were greater than 3, the y values were positive. So again, doing the same problem, just think of it in a different way. Think of a number between 1 and 3. How about 2? If I substitute 2 in over here, I would have 2 minus 1, which is positive squared. 2 plus 2, which is 4 cubed, that would still be positive. And then 2 minus 3 is a negative number. So positive times negative is negative. And again, looking at the graph between values of 1 and 3, your y values are negative. So let's pick a number between -2 and 1. How about let's let x be 0. If I again substitute in here, if I put 0 for x, I get negative squared, which is positive. A 0 plus 2, that's positive cubed, which is positive. 0 minus 3 is a negative number. So again, I end up with negative y values. And looking at your graph between -2 and 1, those y values are negative. Now think of something less than -2 for x. How about like -10? And again, I'm substituting that in here for x. I get positive. -10 plus 2, that's negative. But negative cubed is still negative. And then again, I would have a negative number times subtract -3, and you get negative. Negative times negative is positive. So again, looking over here at x values less than 2, the y values are positive. So again, this is something called a sign chart, or sometimes called sign patterns. So let's go ahead and take a look at number 2 now. So again, luckily for us, it's factored. And so let's think about what we would need to use sign patterns or sign charts. So solving with sign charts. First of all, we only use this method with an inequality. Well, I shouldn't say only, but we're using it with an inequality. So if you're solving an inequality, and then also we need to factor first. You need 0 on one side of the inequality. And again, you have to consider x values as locations of potential y value sign changes. Okay, so what we're going to do then, go ahead and we're going to set this one up with sign patterns. And again, I'm sure you could graph it, but let's practice with our sign chart. Go ahead and decide what values of x we would place on our number line. Go ahead and pause the video, and again, try and find out after you find the values of x that we should put on the number line, what would the y values be, positive or negative? Okay, so hopefully you've taken a look and you realize that 1 is a 0. But notice we also have x squared plus 4, but we don't have a potential for the graph to go above or below and have a sign change for the y values because, again, we have a non-real 0. So that would not make a difference. So what we're going to do is now we're going to figure out what x values would give you a y value of 0, and that would be at 1, less than 0. So we're looking, where are the y values negative? Nowhere, so no solutions there. And then where would the y values be positive? Oops. Okay, so lastly, why don't you go ahead and pause the video and go ahead and graph using bounce pass graphing and check your work. Again, from at 1, we have a y value at 0, and then from negative infinity to 1, and from 1 to infinity, we have positive y values. So that was the right answer. A polynomial function is positive, negative, or 0 for all real numbers, but a rational function can be positive, negative, 0, or undefined. In particular, a rational function is undefined at the zeros of its denominator, because again, you cannot divide by 0. We modify the sign chart to include real zeros of both numerator and denominator as locations of potential sign change. So go ahead and do a sign pattern, or sign chart, I should say, for number 3. Pause the video and give it a try. Okay, so again, zeros are at negative 2 and 1, and at x equals 4, your function is undefined. So what we're going to do is pick a number for x, choose a number larger than 4, how about like 10 or something. So if you substitute 10 in here for x, you would end up with positive, because 10 minus 1 is positive. 10 plus 2 is positive, and divided by 10 minus 4, that's also positive. Pick a number between 1 and 4. For example, 3. 3 minus 1 and 3 plus 2, and those are both positive numbers. And then if we have 3 minus 4, that's divided by a negative. So again, x values between 1 and 4 would give you a negative result. Pick a value for x between negative 2 and 1. How about 0? I would have negative times positive divided by negative, because again, 0 minus 4 is negative. So we end up with a positive y value. And over here, for values less than negative 2, again, you'd have negative. So go ahead and pause the video and solve for x. Put your answer in interval notation. Okay, so again, you're looking for, on the sign chart, where are the y values less than or equal to 0? So negative or 0. So you would end up with negative infinity to negative 2, including negative 2, and 1, including the 1, to 4. But 4 is not included because your function is undefined at x equals 4. Okay, let's go ahead and try the next problem. This one's a little different. So again, the sign chart method can be adapted to solve other types of inequalities. So again, this is not a rational function or a polynomial, but we can still use it. So go ahead and pause the video and make a sign chart. Okay, so at negative 5/3 and at 2. Okay, so after we do number 5, we are going to go ahead and try and use the sign chart to sketch a graph. Try and guess what the graph would look like by looking at the sign chart. So why don't you go ahead and pause the video and solve number 5 and then try and sketch a graph. Okay, so I made my sign chart. I found my solution. Again, I want to know where is this function less than 0, negative. The y values are negative from negative infinity to negative to positive 3, but again, undefined at negative 2, and again, not included at x equals 3. So there's my solution. So I'm going to try and sketch a graph. Now, this tells me that I have an x-intercept at 3, and it's undefined at negative 2. So perhaps there's a vertical asymptote. Not really sure. But that could certainly happen, right? Notice that my y values are negative to the left and to the right of my vertical asymptote until I get to 3. So I'm thinking it probably looks something like this. And then again, my y values are positive from 3 to infinity. So my graph could potentially look something like that. Again, you could check it on your calculator and see how good our guess is. Go ahead and do that now. See how we did. Not bad. It's a pretty good guess. Okay, so let's go ahead and take a look at the next problem. Again, I'm going to have you go ahead and practice one on your own. The first thing you have to do is factor. Then you'd have to make your sign pattern, and then you'd have to figure out what you would choose as your solution. So go ahead and pause the video and try number 6 on your own. Okay, the hardest part about this one might have been finding the zeros. Again, the places where potentially your graph could go above or below the x-axis. So when I did this one, I tried the negative 2 and then the 4, but again, I don't know. I think that might have taken a while if we're just guessing. So after you factor, I did a sign chart. And to be honest with you though, I think I would probably graph this one. We're getting really good at bounce pass graphing. So notice that the bounce pass graphing here, this graph does definitely agree with the sign chart, because for x values from negative infinity to negative 2, we had negative y values. Again, from negative 2 to 3/2, we had positive. From 3/2 to 4, we had negative again. And then from 4 to infinity, positive y values. So if I wanted to go ahead and solve this one, where is this function less than or equal to 0, greater than 0, go ahead and pause the video and try your answer. Okay, so go ahead and check your solutions. And again, you could use it for an inequality. You could solve an algebraic method, would be choose sign charts, or you could graph it. Let's take a look at number 7. Now for number 7, I gave you a sign chart and said, could you draw a graph that might describe the sign chart? So go ahead and give it a try. See if you can graph something that would actually go ahead and agree with that sign chart. Go ahead and pause the video and give it a try. So if we look at this function from left to right, from negative infinity to negative 2, the y values are negative. Then we have zeros at negative 2, negative 1, 1, and 2. Notice we have positive y values, so you must bounce at the negative 1. And then again, from between 1 and 2, the y values are negative. And then from 2 to infinity, the y values are positive. Go ahead and give it a try. Try number 8. And again, for number 8, oh, I should have written undefined here. That is undefined. The function is undefined at negative 1. Give it a try. Sure, there are a lot of graphs that would match this sign chart. But again, if we have x equals negative 1, if that value is undefined, I'm going to call that a vertical asymptote. So between negative infinity and negative 2, the y values are negative. Between negative 2 and negative 1, the y values are positive. So notice my graph would look something like that. Between negative 1 and 1, positive. So again, I have to have asymptotic behavior. And then when I get to the 1, my y value is 0. Between 1 and 3, my y values are negative. And from 3 to infinity, my y values are negative. So I must bounce there, and maybe my graph looks something like that. Okay, so we have one problem left. We're going to try and solve this inequality with sign patterns. Again, that's the only algebraic method we have for an inequality right now. We are going to have to go ahead and think about what we need for sign patterns. Go ahead and go back here and take a look. Remember, I wrote it all down for you. We needed an inequality. We need to factor. We need 0 on one side of the inequality, and we need to consider x values as locations of potential y value sign changes. So for this problem, notice that the problem is it's not factored. So you need to get a common denominator. So go ahead and pause the video and try and make this look a little bit better. Okay, so once you get a common Okay, so now that we got a common denominator, you can go ahead and simplify and factor. We know that we want to find what x values will yield y values less than 0. So go ahead and make your sign chart. So our x values that are important to us right now are at -3, 1, and 7. At x equals -3, those y values are undefined. At x equals 1, those y values are undefined. Y is 0 at 7. So notice again, if you pick a value greater than 7 for x, you would have a positive, because, for example, if you pick 10, 10 minus 7 is positive. Again, then 10 minus 1 and 10 plus 3 also positive, so we end up with a positive y value. Pick something between 1 and 7, perhaps, I don't know, 3 or something like that. You would end up with 3 minus 7, that's negative. And 3 minus 1, positive. 3 plus 3 is positive. So you'd end up with negative y values. Between -3 and 1, choose something like perhaps 0. 0 minus 7, if you again are using let x equal 0 over here. Maybe I need to write that for you. If we had 0 minus 7, and then 0 minus 1, and 0 plus 3, notice you would end up with negative over negative times positive, which is a positive y value. And then pick something less than 3. So again, if I picked something like, I don't know, -10 or something like that, and I substitute that in the x value in for x, I would end up with negative over negative times negative, which is negative. If I need to know what x values will yield negative y values, again, I'm looking where are the negative y values, where are the negative signs. So that's negative infinity to -3 and 1 to 7. Okay, great job, everybody.